Good morning, students. So, part 3 of chemical bonding. The concept is here types of chemical bonds. Types of chemical bonds. As we have learned that chemical bond is nothing but a force of attraction between atoms or ions or molecules. That force of attraction is mainly observed to attain the stability of atoms through the molecules. Now, when coming to the types of chemical bonds, there are different types. Starting from covalent bond, ionic bond, also called electrovalent bond, coordinate bond, also called day-2 bond, metallic bond, hydrogen bond, van der Waals forces. When coming to covalent bond, okay, as I said already, in any bond formation, valence shell electrons are involved. What type of electrons? Valence shell electrons. What it means? Electrons that are present in last shell of an atom. Right. And as you all know that there are different types of elements, metals, non-metals, and metalloids are also there. But when you are talking about the chemical bond, we need to concentrate on two types of elements, metals and non-metals. Metallic atoms, the bond between those two, that is metal and metal, is metallic bond. Metallic bond. Non-metal and non-metal, covalent bond. Metal and non-metal, ionic bond. Electron rich and electron deficient, coordinate covalent bond. Very simple. Okay. Just based on the nature of the element, we can figure out whether the bond is covalent bond or ionic bond, coordinate bond, metallic bond. And then miscellaneous bonds, hydrogen bonds and van der Waals forces. Now let us see in a brief, okay, what is covalent bond, ionic bond, coordinate covalent bond, metallic bond. Covalent bond. Covalent bond is formed between non-metal and non-metal. Hope you know what are non-metals and the location of non-metals in periodic table. Non-metals are placed at the right side of the periodic table. Okay, example, hydrogen, which is placed at left side of the periodic table. However, hydrogen is a non-metal. Hydrogen, same type of elements, atoms of same element, and they are non-metals. The bond is covalent bond. Next, hydrogen, one of the non-metals, fluorine, one of the non-metals. The bond between H and F is, okay, covalent bond. So in simple, a covalent bond is observed between two non-metals, two or more non-metals. How that is formed? So bond is formed due to mutual sharing of valence shell electrons of two or more atoms. Okay, I repeat, bond is formed due to mutual sharing of valence shell electrons of two or more atoms. Okay, even you can see water. Water formula is H2, two hydrogen atoms and one oxygen atom. H2O. Non-metal, non-metal, non-metal. The bond between these three elements, these three atoms, are covalent bonds. How many covalent bonds? Two covalent bonds. One is between hydrogen oxygen, another one oxygen hydrogen. Two bonds. So water is a covalent compound, covalent molecule or covalent compound. So very simple, covalent bond is formed between non-metal, and it is due to mutual sharing of electrons between two or more atoms. Now coming to ionic bond, which is also called electrovalent bond. The name itself indicates bond is formed between ions. What type of ions? Oppositely charged ions. So this bond is formed between metal and non-metal. That you know very well, metal are ready to lose electrons and non-metals are ready to accept electrons. When metal is ready to lose electron, then it can form a positive charge, and when non-metal is ready to accept electron, that will gain negative charge. Oppositely charged ions attract each other. That attractive force is termed as ionic bond. Similarly, you see here NaCl, Na plus and Cl minus. Mg plus 2, O minus 2. That is MgO is a ionic compound. Magnesium lost 2 electrons and oxygen gained 2 electrons. How it is formed? Due to complete transfer of electrons. The transfer of electrons generally observed from metal to non-metal. Electrons are transferred from metal to non-metal. And the metal gains positive charge and non-metal negative charge. That attractive force between oppositely charged ion is ionic bond, also called electrovalent bond. So it's simply an electrostatic force of attraction. Electrostatic, opposite charge. Electrostatic force of attraction between metal and non-metal is ionic bond. Next, coordinate covalent bond, also known as day-2 bond. You see here there is a name called covalent bond. Okay, it is a special type of covalent bond where the bond is formed due to unequal sharing of electrons. That is observed only between electron rich and electron deficient species. For example, ammonia, which has a lone pair. We will see that what is lone pair and all in the upcoming classes. And H plus. H plus is electron deficient and ammonia is electron rich. And the bond between these two is coordinate covalent bond, also known as day-2 bond. Next one, metallic bond. The bond is formed between metal and metal due to loss of electrons. Example, sodium, sodium. Next, miscellaneous bonds, hydrogen bond. The name itself indicates there must be a hydrogen to see hydrogen bond wherever that is observed. So here bond between H and F. Okay, hydrogen is less electronegative, fluorine is more electronegative. H2O, here oxygen is more electronegative, in HF hydrogen is less electronegative. The bond between hydrogen and oxygen, even hydrogen and fluorine, is hydrogen bond. Next, van der Waals forces, they are observed in between the molecules, So NaCl is ionic compound and water is a covalent compound. So the bond between NaCl and H2O is a van der Waals forces. Right? This is all about types of chemical bonds. So just based on the nature of the element, one can figure out the nature of the bond. Non-metal, non-metal, covalent. Metal, non-metal, ionic. Electron rich, electron deficient, coordinate. Metal, metal, metallic bond. More electronegative and hydrogen bond. Van der Waals forces between the molecules. Right? Now let us study ionic bond in detail. Ionic bond. The name itself indicates the bond between ions. When ions are formed, when one species is ready to lose electrons, the other species is ready to gain electrons. That means one species can gain positive charge, the other species gain negative charge. Species with positive charge, imagine that Na plus and Cl minus, positive, negative. Complete positive charge, complete negative charge. So that you know very well, oppositely charges attracts each other. This attractive force is called electrostatic attraction. Electrostatic attraction. Electrostatic, even we can say force of attraction. Electrostatic force of attraction. So what we can define? Ionic bond is nothing but an electrostatic force of attraction between oppositely charged ions is ionic bond. So it is an electrostatic force of attraction. Electrostatic force of attraction between oppositely charged ions. Oppositely charged ions. Example, Na plus and Cl minus. Another example, MgCl2. MgCl2. So here magnesium loss transferred to electrons. One for first chlorine, the second electron to second chlorine. So finally here what we can see, Mg plus 2 and 2Cl minus. The force of attraction between Mg plus 2 and Cl minus is ionic bond. So here how bond is formed? Due to complete transfer of electrons from metal to non-metal. So ionic bond is formed due to complete transfer of electrons from metal atom to non-metal atom. Metal atom to non-metal atom. Why metals are ready to lose electrons? To attain octet configuration. Why non-metals are ready to gain electrons? Again to attain octet configuration. Now let us understand more clearly, okay, how metal is providing electron to the non-metal, or how non-metal is gaining electron from metal atom, and how many electrons are transferred. Okay, one by one examples. So ionic bond is just an electrostatic force of attraction which is formed due to complete transfer of electrons from metal atom to non-metal. Don't imagine that complete transfer means all electrons are transferred to non-metal. Only valence shell electrons are transferred from metal atom to non-metal. Only valence shell electrons. Now examples. Example 1. Sodium fluoride. So here in sodium fluoride, sodium is metal and fluorine, that is non-metal. Metal and non-metal. Now here sodium symbol is Na and fluorine symbol Fe. Let us understand how the force of attraction or the bond is observed between sodium and fluorine. If we want to understand it, we must be thorough with electronic configuration. Now let us see the electronic configuration of sodium. 1s2, 2s2, 2p6, 3s1. 1s2, 2s2, 2p6, 3s1. Fluorine 1s2, 2s2, 2p5. Since its atomic number is 7, here sodium atomic number 11. Now when you see that shell representation or orbital representation of sodium and fluorine. Here sodium with the nucleus, first shell, second shell, third shell. Here in sodium, in first shell, there are 2 electrons. Second shell, 2 plus 6, 8 electrons. 3, 4, 5, 6, 7, 8 electrons. Third shell, which contains only 1 electron. Okay, so this electron, this shell is called valence shell. Valence shell. Okay, and the electron present in valence shell is called valence shell electron. Valence shell electrons. How many valence shell electron? Only 1. Now coming to fluorine, where there are 9 electrons. Nucleus, first shell, second shell. Okay, electrons are there in only 2 shells. First shell contains 2 electrons. Second shell contains 7 electrons. Okay, so here is the vacant. Okay, only 7 electrons. So here, this is valence shell. And this one is valence shell electrons. Sodium and fluorine both are unstable in their atomic form because it has only 1 electron in its valence shell. To attain stability, it must have 8 electrons in the valence shell. Similarly, fluorine, it must have 8 electrons to attain stability. But here there are only 7 electrons. So here, if it wants to attain stability, there are 2 ways. One is losing 1 electron or gaining 7 electrons. Which one is more preferable? Losing 1 electron is more preferable compared to gaining 7 electrons. Okay? Now here, to attain the stability, either it must have 2 electrons in its valence shell or 8 electrons in its valence shell. So here there are 7 electrons. So to attain the stability, it requires only 1 electron. That is more preferable compared to losing 7 electrons. So sodium is ready to lose 1 electron and fluorine is ready to gain 1 electron. So sodium is ready to transfer 1 electron to fluorine. After losing 1 electron by sodium, the configuration is going to be 1s2, 2s2, 2p6, which is equal to neon configuration. And the charge on sodium is Na plus because it lost only 1 electron, so 1 positive charge. Now after gaining 1 electron by fluorine, the electronic configuration is 1s2, 2s2, 2p6, which is equal to neon configuration. Neon configuration. Now after gaining 1 electron, the charge on fluorine will be F minus. Now we have ions, rather neutral atoms. So here positive charged species, negative charged species. So they attract each other. This force of attraction is ionic bond. So finally what we can write? NaF. NaF. So NaF is formed due to transfer of 1 electron from sodium to fluorine. So therefore this compound is ionic compound. Since there is an ionic bond, therefore the compound is ionic compound. The bond between sodium and fluorine is ionic bond and the compound is ionic